All right. Okay, so as you guys go through this packet, um, one thing this chapter has been emphasizing is like you're starting with some kind of function, and that function is changing. It's going to be, it's changing based on what you add to the function, what you multiply the function, and you're doing that in different parts of it. Okay. So, for instance, if we're looking at this equation, this function right here, what kind of graph is that, or how do you describe it? And what are you called? Parabolas. Okay. Parabolas have a couple different names. Okay. Parabolas are not just called that, they're also called quadratics. Okay. They're quadratic functions. And this, again, notice how I put kind of the Cornell notes, a little side notes here. So have a little column over here to the side if you don't have that already. Okay. And the formula for a quadratic function is y equals a times what? What goes in here? X what? No, minus h, and then what goes up here? Squared plus k. Okay, so that's the basis for that function. Okay, we start with that as we're creating the function. So we're going to look. I'm going to give you a picture, and then based on that picture, you have to create the equation. Okay. This is also called what form? Is this standard, graphing, or factored? Graphing form. So for all of these, we're going to use graphing form. Okay. The other one you guys are going to see over here is this guy. Now, what I want you to notice is that if I take, let's say, this half down here, and I kind of draw it like this, look what it becomes. Don't draw that on your packet, by the way. What does that look like now? A U. So it's almost like half of the U has been turned down. Okay, and the other half is still right side up. Okay, does anybody know what this one is called? That one is called a cubic. A cubic function. What number do we usually associate cube with? 3. So it's literally the same thing, y equals a times x minus h, but instead of square, now it's cubed. Okay? All right, now another one you guys are going to see on here is a straight line. Now you've been seeing straight lines since 7th or 8th grade, and what are the equations for that? Okay, it is a linear, and what's the equation? Right. Okay, so for this section, that's what we're doing. The other one that's not on here that you would see mainly in IXL, there's an IXL assignment for it left from last week, is absolute value. So absolute value, and what does that look like? What does the graph of an absolute value function look like? It's that guy. It's a V. So this one, let's draw a little mini graphs here. So linear, straight line. Cubic looks like a half parabola, where half is going up and half is going down. And then quadratic is just the parabola of the U. Okay. So let me pause for a second, see if I can time this all up. All right, so let's say I've got a graph. So here's example 1. And I make a little graph. I'm going to start here and go down, let's say 7. The axis will be 7 units long. Okay. And then across, I'll do like, I don't know, like 8 units, I guess. About that much. I am going to put the vertex, the middle of the graph, right there. Okay. So it's going to be 2 units over. and 1 unit down. Okay, so then I'm going to draw a point like this. I'll have a point here, and then I'm going to have my next point 2 over and up. So right there. So that one's at 4, 4. This one's right at 3, and this one's at 4, 4. Okay. The next one over here, if you mirror it, remember parabolas are symmetrical, so all I got to do is go mirror it over to this side, which is right there, 3 up on the y-axis. Okay. Okay, and what's helpful actually to draw those is if you draw that line down the middle, that line of what? What's that called? Symmetry. As long as I have one side of those points, all I got to do is mirror it to the other side. So if this is 2 units away, I go 2 units away on this side. This is 1 unit away, I go 1 unit away on that side. Okay, now I just connect my dots. Make the nicest U possible there. All right. Now I got to come up with an equation. Okay, again, which of these functions or these equations am I going to use? All right, the quadratic one. All right, so I'm going to set that up. So y equals a times x minus h squared plus k. What numbers do I know to plug in there? Or what numbers do I plug in right away? Where do I look? Daniel? H and k. So what is the h? What is the h and k? I heard somebody just say it. What was it? Vertex, yeah. And the vertex is right there. It's the middle. So we're at 2 and minus 1. Okay. So if I got 2 and minus 1, I'm going to write a times x what? Minus 2. Good. And then do I put plus 1 or minus 1? You keep it the same sign. Which one changes signs? The x or the y value? Which one? The x value. Notice this is positive, so that's going to be negative. Okay, but the y value of the vertex doesn't change. Okay, but notice again, now I have that a value. I still got to find the a value. So what could I do to find the a value? I got to plug something in. What can I plug in? Okay, I can choose the y-intercept. Do I have to use the y-intercept? What else could I use? Yeah, I can use either of the x-intercepts. Okay, I can use any. Which one can I not use? That wouldn't work. So which one of those points? The vertex in particular. Because what happens when I plug in the 2 right there? Yeah, it cancels out your a and you can't solve for it. So you can pretty much plug in anything but the vertex. Okay. So I'm going to choose let's go with this guy. All right, we're going to plug in the x-intercept. Okay, and that x-intercept is 3, 0. So let's plug that into your equation here. So now here I've got 0 equals a. Plug in the 3, minus 2. Okay, now I'm just simplifying. So now 3 minus 2 is 1. 1 squared, 1. So this is just a. And then the last step, add 1. And a equals 1. So that one, there really is nothing special for the a. Okay, just plug in that 1. Okay, and since it's just 1, I don't really even need to write it. Okay. So again, the main part is I got to know the vertex. I take that vertex, I plug it in, and then I got to pick a point to find the a. Okay. All right, let's look at another example. Okay. This one I'm gonna do like kind of about 8 by 8 for the next one. And for this one, let's do a cubic function. So I'm going to start this guy right, I don't know, let's go right here. Okay. And we're going to go, I'm just going to start making this up here. Let's go wider like this. Okay, like that. So I got 1 point here at 3 and 2. I don't care where you put this point at. We're just going to end up using that one anyways. Okay, and then we're going to go down. So the vertex or the middle point is going to be right here at 1, 1. And then I'm going to go down here to negative 1, 0. And then start to go down from there. Okay, so we'll just do it like that. Okay, now cubic functions don't have vertexes, but they do have a point in the middle, just like a vertex. Okay, what you'll see that called sometimes, they'll call it a locator point. It serves the same purpose, but they'll call it a locator sometimes. Okay. All right, so for this one, that locator is just 1, 1. All right, now, instead of using this formula here with the squared, all I change is to what? All right, just change it to cubed. So now y equals a, x minus h, cubed plus k. Okay, and now I'm plugging in the vertex just like before. X minus what here? Is it x minus or plus? Okay, it's minus. Remember, the x value, you change the sign of the x value. But what about the y value? That will still be plus. Okay. If you think about it, look at the formula. The formula says minus, right? So you just plug it in with the minus. But if it was already a negative, it almost becomes like negative, negative, and makes it positive. Okay. All right. So now, what can I plug in to figure out the a value? 0, 0 is not on the graph. 0, 0 is here. 3, 3? 3, 3 is here. 3, 2. I need to pick a point on the graph somewhere. Okay, what else could I use? Negative 1, 0. Can I use 1, 1? No, it's going to cancel the a out. Remember, don't use that middle point or the locator point or vertex or whatever it's called. All right, so let's use this guy. All right, so this is 3, 2. So 2 goes here. 3 goes here. Now this looks a little different than the last one. What's that? Oh, forgot to, I put that in the wrong place, didn't I? A, that's the A, 3 goes here. Oh, my fault, my fault, my fault. Thank you. Cubed. All right, so now I got to solve for A. So first let's just simplify right here. 3 minus 2, 3 minus 1 is 2. 2 cubed. Multiply 2 3 times. What do you get? 8. So this will be 8A. All right, so then subtract the 1. You get 1. Last step. Divide the 8. That becomes 1. And then A equals 1/8. So that's your A value. That's what goes in front of your equation. So now the final equation is going to be 1/8 x minus 1 cubed plus 1. Okay? And leave it as a fraction. Don't write that as a decimal. Always leave it as a fraction. Okay, so again, no matter what kind of equation or type of parabola you have, you're going to basically take the center point take another point and plug it in. Okay, and you should end up with the correct A value. Now, as I'm solving for, let's say, this guy, what will that A value end up being for this guy? What do you guys think? Negative. Why? Right. So if it's got, we call that concave up, will be positive, concave down, you'll end up with a negative. So if you don't end up with a negative, you did something wrong. Or maybe you just forgot to divide the negative, that sort of thing. So make sure you guys are seeing that. Okay, this one I'm gonna let you guys handle that on your own. This is just y equals mx plus b. You need the slope, rise over run, and then you need the y-intercept. Okay. All right. So that's it for the notes. That should be enough to help you guys get through that section. The back side of that, real quick. This one you're just sketching this graph out, by the way. Graph and describe the function. So you guys can use Desmos for this. Okay, for the square root function. For these two, does anybody know what kind of shape this creates? This type of function? If you look down here, it says, look at the questions. Find the following, the center and the radius. What kind of shape is that? The circle. Okay, so that's going to create a circle. Okay, so you guys can use Desmos if you want, but you'll learn how this, you can actually just use the equation to graph that. Okay. All right, so guys, go ahead and get started with whatever you guys need to work on. Packets. Hey, by the way, if you guys want to go